let's do this question. Can you write the charge balance for a solution containing all those? Okay, we have water molecule, hydronium ion, hydroxide ion, perchlorate, ferrocyanide, cyanide, iron 3+, magnesium ion, and 3 molecules, and then ammonium ion. Okay. So the general step is, first of all, you write down, you separate the cations and anions. Doesn't matter which one goes to which side, just separate them. So I have one group of cations and one group of anions. Okay. And then you look at the charge every ion is carrying. If it's carrying 2 charge, you will multiply it by 2. If it's carrying 3, you will multiply it by 3. Okay. All right, so first of all, let's count all the cations here. Where are all the cations? We have hydronium ion, we have iron 3, we have magnesium 2, and we have ammonia here, right? So on one side, I have hydronium ion, iron 3, magnesium 2, and NH4+. Okay. Please keep in mind, you always need to show this bracket, okay, to show it's actually a concentration. All right, so this is the cation part. And what about the anions? We have OH minus, perchlorate, have ferrocyanide, cyanide ion, cyanide ion. Okay, so we have OH minus 4. Okay. Now, the final step, consider the charges. Okay, so what do I have to add here?
3 on Fe.
3 on Fe.
2 on the magnesium.
2 on the magnesium.
3 on the ferric cyanide.
Yes, and 3 here. That's it. All right. So the 2 steps, right? Number 1, separate the cations and anions, put them in on both sides of the equation. And the second step is add the coefficient. Depends on whether each ion is carrying 1 or more multiple charges. All right. Okay. Any questions here? You don't consider neutral compounds because they don't carry any charges. Right? We're thinking about a charge balance, so you only consider the compound has charges. Yes, they're just ignored, so you don't consider this because they don't carry charges, right? They don't affect the charge neutrality.
Professor?
All right. Yes.
I don't get it. Why is the positive charge equal to the negative charge? Like, how do you look at that and you say it equal?
Because the solution has to be neutral. You cannot have a solution that is charged. Overall, it's neutralized.
No,
Although
I mean, because I looked at the equation after you put the coefficient, and then I calculate, they don't seem to be equal. So that's why
yeah, as I said, okay, it's not simply, so when I write iron 3 plus 2 magnesium, you are not doing 3 plus 3 multiplied by 2 plus 2 because they have different concentrations. So it's not a simple 1 plus 1 question. You're considering, so it's not, we don't have 1 mole of iron in the solution. We could have 0.1 mole iron, and we could have 0.2 mole magnesium. Okay, so it's not simply you're calculating 3 multiplied by 3 plus 2 multiplied by 2. Does that make sense? You're calculating 3 multiplied by 0.1 molarity plus 2 multiplied by 0.2 molarity, something like this. But we actually don't know the concentration of each ions in this case, right? So we use the formula, we use the concentration symbol to represent the concentration. Does that make sense?
Not really. So if we have like a problem, it will be easier to see.
No, it's okay. So coming back to the initial statement I said, when you're dealing with equilibrium problems, you always have to deal with a lot of species. So it means that you will have a lot of variables. And to solve for different variables, you will need to set up the system of equation. Right? How do you set up the system of equation? You can set up the equation using the equilibrium constant, but that's not enough for solving more than 2 variables in the solution. Because of that, we utilize the charge balance and mass balance to be able to set up more equations using of the variables, so that later on you can solve for different concentration in the solution. So the actual concentrations of different ions are actually unknown, but we know that in natural, when you have a solution, the total amount of positive charge should equal to total amount of negative charge. Okay, that's essential. And we're just using this rule to write up a new equation with different variables. Okay, but again, it's not when I'm writing this way, I'm not multiply 3 by 3. And multiply 3 by the actual concentration of the ions. And if you know the concentration of all ions, when you do the calculation, the positive should equal to negative. Okay, but right now we just don't care about the concentration. We just write down the equation, okay, using the concentration symbol, and it should stand. This equation should stand. Okay? It's just because a solution should be neutral. Okay, that's how it works. I don't know whether that helps a little bit.
This help. Thank you, Professor.